As you know, I'm Kanchan the Tech Pro, and in this lesson, I'm going to take you through step by step on how to build a machine learning model in C# using Visual Studio, and we are going to be building a machine learning model for predicting prices. Actually, in this case, we are going to be predicting transport fare prices, and later on in the next tutorial, we are going to build a model to predict stock prices, which is a bit more challenging. So let's start, and we are going to do it step by step. All the source code you need, all the steps you are going to follow is available here in my website. It's in the description box below. You can find it here, the step by step. All the source code is also provided here. In case you miss out something, you can just go copy the source code and use it to do the work. I would like to remind you to subscribe to my channel by hitting the subscribe button below this video right now, because when you subscribe, you kind of motivate me to keep making these lessons. And take note that these lessons are very easy to the point. They are for beginners, they are for intermediate, and for people who already have a bit of knowledge of programming or even not. So please hit the subscribe button and leave me a comment if you have any challenges following any of my tutorials or any of my lessons I've been making over the past few years. And like the video, share it around. If there are people you might know it might help, you never can tell, so share it around, and also do let me know how you feel. So let's go ahead to get started. Now we need Visual Studio 2017, as you can see right here in the prerequisite says Visual Studio 2017. Now it's free, you don't have to pay a dime. You need to go to the website, download it, and just set it up in your system. It's very free to use. So I've downloaded and installed, so I'm going to simply open Visual Studio and let's get started. So Visual Studio opens up right now. So I use Visual Studio 2017 Community Edition. Is very free. I recommend if you're a learner, don't buy anything, just download it for free and use it to follow this lesson. You can become a very good data scientist, and machine learning expert without paying a dime. So this opens up in my second monitor, so I'm going to just drag it. Alright, so it's open, and now we are going to take the first step. Now I'm going to kind of restore it to this side so that we can be seeing the step by step and also working at the same time. Alright, so everything is okay. So step one, obtain the data set. Now the data set is available from here. Download it from there into your system, in the folder in your system. You'll need to download the training and the test data set. So I actually say download it from here. So after now, you check the description box, you'll find a link to where you can get this file. Let me just open the data file in my system so that you can see what this data file actually looks like. As you already know, in supervised learning, we have the training data set, we have the test data set, and even in unsupervised learning. And in this case, we are talking about a labeled data. So we have the taxi fare train. I'm going to open it using Microsoft Excel at this point because it's a .csv file. We also have the .txt format in case you have any of them. But in this tutorial, we are going to be working with .csv file. So if you have it, that is great. Open it with Microsoft Excel and take a look at how the data looks like. You see that it contains a number of columns and then the transport cost, what the cost of the fare will be. So you can predict how much it will be based on certain parameters that include the vendor ID, the trip, the distance from the location to the destination that the taxi takes you, the time it takes to go from that the source to the destination, the payment type, whether you are using a credit card and they are using cash and stuff like that. So given all those things, like you can see vendor ID. So I'm just going to increase the fonts a little. Alright, so you can see vendor ID, rate code, passengers, passenger count, whether there are 2 or 3 passengers or just you, 1 passenger, trip time in seconds, and so on and so forth. So given all these, we are going to predict the amount. So this is the amount, we are going to predict this amount, and this is the class or the label. So given all these features, we are going to predict the label or the class. And in this case, this is actually a problem of linear a problem of regression and regression analysis. That is what we are going to be doing here. Not logistic regression, just regression analysis, because we have the fair amount is continuous. It can be 1.2, 1.3, 1.4, 7.5. It's just continuous range of values. But if it's discrete values, 0 or 1, that is now logistic regression. All right, so let's go ahead to get started, shall we? Okay, so let's get to Visual Studio. I've obtained my data set, save it somewhere in your system, and I'm going to start a new file, new project. So the instruction says create a console application and use .NET Core. Create a console application and .NET Core, that is where it is. I'm going to call it transports. Okay, let me just call it price prediction demo. Okay, so I've created it right now. The next thing now is to create the folder in the solution that is going to hold the step says install the Microsoft.ml Nugget package and also Microsoft.ml.fast3, because it seems it's using a decision tree model, but I don't know. But this is what is required. So it's trying to set up the project, and at this point, let me just shift this a bit. And I'm going to kind of reduce the font size for this so that we will be able to see a bit more on the screen. All right. So now we have the project set up. So in our Solution Explorer, you can see we have only one item, program.cs file. It says hello world, but we have no business with this. So the next step says install the Nugget package Microsoft.ml and Microsoft.ml.fast3. To do that, so right click on your project and choose manage Nugget packages. From manage Nugget packages, it's going to bring up the dialog box right here. So go to browse, not install, just go to browse and type Microsoft.ml. Microsoft.ml, trying to populate. Microsoft dot let's see, Microsoft dot. All right, so Microsoft.ml, and it finds it out. Once it comes out, you simply click on it, the first one, and simply install the latest version. Simply install. It's going to bring out some license, some policy or stuff. So you need to accept the agreement and stuff like that. After now, we are going to search for Microsoft.ml.fast3. All right, so let's see. So as I was saying, let's just talk about the dataset. The dataset have series of features. Using these features, we are going to predict the price, right? So these features have to be provided in one class, and the prediction of the price have to be in another class. Meanwhile, let's accept this, and it installs Microsoft.ml. All right, so it's installing, so we give a second. So if you just go down to output, you can see the installation progress right down there. Everything installed successfully. And let's now go to look for Microsoft.ml.fast3. So you can see this as well. So we also have to install it in our solution. All right, so the first one, it says .NET component for fast3. So you can read it up in the location here, you can read it up. So just go ahead to click on install. Now the next thing we are going to do is to create a data folder in our solution, and this data folder is where we are going to place the training data set and the test data set that we downloaded from the repository. And you can look in the description box, you'll find these two CSV files and you can use it for free. Okay, so the installation is going on, as you can see right here in the output section. So there's nothing much we can do than to just wait for it to complete the installation. And one thing I'm going to tell you that this is very easy to do. I'd like to recommend you don't give up. If you have challenges, leave a comment for me to let me know. Also check that you are subscribed by hitting that subscribe button if you have not subscribed. Now everything is okay. I'm going to just close the Nugget Package Manager Let's remove this hello world because it's useless. We don't need it. Just take it out from there. Okay. And the next thing, go to the project and add a folder that is going to contain the data set that we are going to be using. So I'm adding a new folder. As you can see, I'm going to call it data. You can use the same name I use. The name doesn't matter for much, but this is the name I use. So the code is going to reflect this name. Unless you know what you are doing, you can change up things a bit. But I say do it the first time with me the way I'm doing it, after which you can change up things a bit to see how it works. So right click on the data and just add the right click on the data folder and add existing items, and you are going to browse where you save the original data set. And for me, I saved it in my drive D. I saved it in a folder called data, and I'm going to just say all files and start to taxi. I have taxi fare CSV and taxi train fare train.csv, two files. So we have the two data sets, the training data set and the test data set right here. We are going to set the properties of this file. As mentioned, copy to output directory properties. So in this case, these files will be available in the output directory at runtime. So just go to properties, and instead of saying do not copy, just say copy if newer. Okay. All right, so we are making progress, and the next step now is to create the classes. The first class, we are going to call it taxi trip. It's going to hold all the attributes of the data. In fact, everything in the original data set. I'm going to create the mapping in a class. So I'm going to just create a new class. So right click on your project and say new, add new item or new class to make it easier. A new item, you choose class. You can also say new class is also very good. And give it a name, taxi trip. So this taxi trip is going to represent our data set, and I'm going to accept. Now this taxi trip is going to have vendor ID, rate code, passenger count, exactly the same thing we have in our data set in the CSV file. That's exactly the same thing we are going to define. So what we have in this class is going to map to what we have in the CSV file. So I'm going to just copy the content here. Now I'm going to copy the content and just paste it right here. As you can see, now it's going to give me error message. Error message says load column is not found. This load column is available in Microsoft.ml.data. So if I save everything and I go to check, it says show potential fixes, and it's going to give me option to add using Microsoft.ml.data. That is where it is. Alright, so I'm going to just use Ctrl S on my keyboard to save everything, and the next one I'm going to do, I'm going to add a second class that is going to hold the prediction that has been made. So again, I'm going to right click on my project and say add class. The name of this class is taxi trip fare prediction. So I'm going to copy the name and use it instead of typing it so we don't waste precious time. Alright, so this is the prediction now. So given all these features, make prediction. After making prediction, we're gonna compare this prediction we made to the actual fare, and maybe you know that if you design a model, the model makes prediction, there will be a little error. The problem is, let this error not be much. Let the accuracy percentage be high enough. So taxi fare prediction is going to make prediction, whereas we also have the fare amount here, and we are going to compare the two and see how our model is doing. Now we've added the prediction class, and the next step says define the data and model paths, right? So we need a path in the class path, in our application class path, to store the training data set, the test data set, and the model that is being completed. Because when we complete building this model, we are going to save this model so that we can use it. Because the benefit of building a model is so that you can use it to make predictions later on. So this code here, actually, there are only 3 lines of code, but there's no space. So that is why everything is just in one line. So I'm going to copy it and paste. I'm going to paste it this time. It's going to be in the main class. Where is the main class? The main class is actually program.cs, and we are going to put it, they are static classes, meaning that is only one copy of this part is there. So you can't instantiate this class and create copies of this part. There's only one part for each of them, each of the three. Now, I'm going to kind of maximize this so that you can see the complete line of code. So you can see you have train data parts, test data part, and we have parts, model parts, all right? And how we are using combined environment, current directory, data, taxi pay, the CSV. Basically, this is where we are talking about this place, this file here, all right? So parts is available in system.io. So we are going to use potential fixes using system.io. The parts, the path namespace is available in system.io namespace. All right, so there are three functions we are going to be writing. We have the train function, we have the evaluate function, and we have the make prediction. The train function contains all the steps to build this model and train this model and then return it. The evaluate function is going to evaluate the model, comparing the output of this model with the correct output in the dataset and provide us with an accuracy score, how this model is doing. Of course, when you are performing regression, some of the evaluation metrics include the R metric, the R squared, the percentage accuracy, and stuff like that. And finally, we have the other method called the make prediction. So this make prediction is going to take a sample of an input containing features like taxi vendor ID, the trip time, the distance, and stuff like that. And then it's going to make a prediction and return a prediction. So let's start with the first one. So now the code for the training is much. Now in the web page right here, you may not be able to understand everything because it's kind of wrapping the lines of code, so it's not clear. I'm going to copy it and paste in the program.cs, because all these three functions we are going to write, they are going to be written in the program.cs file. So, and when it's written there, then we are going to execute it from there. So permit me to copy everything, and I'm going to actually explain line by line for you, but maybe you read up some of them for yourself, but I'm going to explain it in a way that is going to be clear enough for you to understand. So I'm going to paste everything, and we have iTransformer, just show potential fixes. It should be Microsoft.ml, and everything is okay. Permit me to just check. Somebody has been buzzing my phone. Let me check. Okay, so I think everything is fine. I think there are some friends here and there that's trying to. Okay, so let me maximize the Visual Studio window, and then we try to explain what is happening here. I actually added some annotation on this code to make it clear for you. So the function is called train function. The train function takes the ML context and then also takes the data path to where the data is stored. The first thing it does is to put all these data sets into a data view, because before you train a model, you need to place that model or the data set into a data view. So we are going to create a data view object to load the text file from the CSV file into the data view and specify the separator. Of course, it's a CSV file, so comma separated variable. So that is the line. Try to understand it, but maybe you don't memorize it. Now we need a pipeline. Now, of course, you know what a neural network is. A neural network goes from layer 1 to layer 2 to hidden layer all the way to the output layer. There's a connection between the input layer containing the input data set going through the hidden layer. Depending on how many layers there are, there may be one hidden layer, there may be two, I don't know. It goes all the way to the output and provides in the output of the data set. So this movement of data from the input all the way to the output is called a pipeline. In that night, now it's neural network we are talking about, but here we call it a pipeline. All right, so When we are creating a pipeline, we specify a number of things. So in Microsoft Teams, we use .append to specify different things. Now we have .append, these three lines I have here, converts categorical variable to numbers because you can't use text variables or categorical variables. So using one hot encoding, these three lines converts the vendor ID, the rate code, and payment type to numbers and store them in another variable called vendor ID encoded rate code encoded. It encodes them into numeric values. And finally, it concatenates all these features into one and then adds a trainer to the pipeline. A trainer is simply a machine learning algorithm that we are going to use. And the trainer here is ML context regression, the trainer is the first tree. So it's simply a learning algorithm. This is basically very easy to understand if you have knowledge of machine learning. But for now, just understand this is what is happening here. Then we create the model. When you create the model, is the same in every language. Just fit the model using the data set. Give the training data set to the model, and the training occurs at that point. After training at that point, you now return the model back. So the train function is going to return to us a trained model. Okay. So that is how the train function works. Let's now talk about another function, and this function is going to be called evaluate. The evaluate function actually evaluates how our function performs and outputs the accuracy and other metrics out to the console using console.writeLine, which is something you already know if you're a .NET programmer. So all these lines of code is very little. All this is just writing out something to the output. Permit me to copy this code and paste it. It becomes clearer because in my website here is wrapped, so it's not clear. If I paste it on the .NET window, the .NET file here, it becomes quite clear. So I'm going to just copy it, and then I'm going to just come here and paste it right here. So this is the evaluate function. Basically, it's only 3 lines of code. Other lines are just console.write. The first one is taking a data view. Yeah, all right. So we have the same data view, but this time we are loading the test data set. If you are evaluating a model, we are using the test data set, not the training data set. When we are training the model during the train function that we have up there, we use the train data set. In this case, we are evaluating the performance of the model. We are using the test data set. Hope it's clear. If not, leave me a comment and let me know. And we have the data view, then we are going to make prediction using model.transform, and that is what we use to make predictions. So we are given it the test data set and tell it use this test data set to determine the transport phase. The test data set does not contain the transport cost. Take note of that. The test data set does not contain the classes. So we are going to make predictions to determine the classes given the test data set, which is only feature set. After that, you are going to now generate metrics by using the regression, the evaluate method available in the regression method of the ML and of the context. So I say metrics is ML context of regression that evaluate. Give it the predictions you made and give it the label, the name of the column which represents the output, and also the score, where it's going to store the score. All right, so if you look at the prediction, you can see prediction. Oh, our prediction is empty. Taxi fare prediction is not complete. So I think I'm missing out something. I missed it out. Yeah, good. I remember it right now. So this is the content. This is the content. So let's not miss it out. So it contains the score. Perfectly okay. All right. So okay, we have this. It should be available in ML the data. Microsoft ML data. That is fine. All right. So so we now want to go down, and finally we need to write a function to take a single prediction and give us a prediction and output. So take a single observation or a single measurement that contains features, and then output, so spit out the fare, the transport fare. So that is what is happening here. Permit me to just copy it and just paste. So now this is basically put it in program.cs. Now everything is also clear in my website. You can pause the video, take step by step to read it, and be doing it step by step. Keep the window open, keep your laptop open, and be doing it step by step. It's going to be clear for you. Now, don't worry yourself if you don't understand everything at this point, but try to follow up the procedure and make sure that you get it working. That is what you should do. Gradually it becomes clear. We are still in tutorial 2. We are going to cover a whole lot of tutorials. If you follow the tutorials and make sure you understand it, perfectly fine. Alright, so get back to program.cs. This time we are now trying to make a prediction, and we have test single prediction. That is the name of this function. Test single prediction takes a single prediction, okay? Takes a single prediction and makes a prediction by using prediction.predict. Prediction is equal to predict function.predict. So you can see predict function is available in the prediction engine, or it's a prediction engine, and it takes whatever input you have here. So it predicts the fare amount and prints it out to the output. You can see fare amount, formatting it in this way, and actual fare is this. So actual fare is 15. So basically actual fare, I don't know, that I don't know. So you need to figure that out. So maybe you go back into the text data set and find out which fare corresponds to this. So I did not remember to check this. So the actual fare is there in the test, in the training data set. Maybe also, maybe not. Maybe this actual test data, actual fare that was measured that I don't know. We are just predicting it. So we are predicting it, and they are telling us that this is actual fare 15.5. All right. So finally, let's now fix everything together. We train the model. We train the model. We evaluate the model and make prediction. And this we are going to do in the main method. Now the steps are also there for you. So I'm going to just copy from here. So I'm only want to copy the content of the main method into the main method. And simply we are calling the trade functions. It's as simple as that. Trade functions, we wrote the trade function, call the trade functions. It's as simple as that. So I'm going to just paste it here. Create the context. ML context is like the environment for you to do training and prediction. And create the model. By training the model, evaluate it and test the prediction. Spit out the output for us and see how our model has done, whether it's done well or not. I'm going to save everything. And let's just make sure we are following all the steps. So at this point, if you got to this point, let's now hold our chest and test everything to make sure everything is working. So at this point, I'm going to just click. First, I normally like to build solution. So make sure everything is okay. So if you look at the output here, you can see build started. So let's give a few seconds to allow it to complete the building process. Okay, perfect. So build succeeded, everything is fine. I'm going to just click on run. This green button here says run. I'm going to click on it. Now the training process actually takes a few seconds to complete. So we are going to wait for a few seconds for it to start the training. Now I'm going to just drag the screen. Now somehow I should have added some kind of counter that is telling us the progress of the training. But for now I didn't add any counter. So it's displaying this black screen. This black screen here, while the training is ongoing, the black screen is there. I don't know if I should just step out a bit to take some water or not. Okay, I can just have a little water. Let me just take a little water while we wait for the training to complete. I really don't know how long this thing is going to take to complete, but I think it's going to complete right now, because the last time I tried it, I think it took about 35 to 40 seconds, but In this case, I think maybe it's going to take up to 1 minute, maybe 50 seconds, I don't know. Let's just wait patiently at this point. So let's see. So one thing I want to recommend is that if you follow my lessons in ML.NET, believe me that in 6 months or even less, you are a complete data scientist. And also take note that Microsoft is stepping up its game, because in Azure they now have different machine learning and analytic model tools that you can use, stream analytics, to capture data from IoT devices. We have machine learning uh, services there that you can use as well. So it's taking some time. So let's see. So training takes time. So I think I should allow it to just complete. If not, maybe you can try to fast forward the video, because I'm actually not going to cut out anything from this video. I'm going to wait for it to complete training. And yes, so now the training completed. It tells us the R squared is 0.917, which is a very good one. The error is 2.8, which is not bad. Continue. So it predicted 16.3, while the actual fare is 15.5. We actually did not so bad. So the error is not quite much, but we can improve this model by adding something called an optimizer. We are going to be talking about this later on in this series. Remember to subscribe by hitting the subscribe button, and also leave me a comment to let me know if you have any challenges. And then we are going to see in the next lesson.